Hello my dear children, this is my class 11th chapter going on, structure of atom. And now today there is a turn of Thomson atomic model. Before that we have discovered electron and proton inside the atom. Now we have discovered electron and proton. Electron discovered in a cathode ray experiment, and that is the proton discovered in anode ray experiment. It's a J.J. Thomson experiment. It is your Goldstein experiment. Because now we came to know inside the atom there is electron and proton. Now question is, what is the position of electron and proton inside the atom? To know the position of electron and proton in the atom, there are various models proposed. Write on the first model. Write on for what purpose this model? To know the position. To know the position of electron and proton. Various models proposed. The first model, write down Thomson. Now listen to me carefully. On that day I told you mass of the proton is 1.67 into 10 to the power minus 24 gram. And student, do you know the same masses of the hydrogen atom, of a single atom of hydrogen? So this is the reason Thomson proposed a model. Thomson said proton mass and the single atom of hydrogen mass is same. Mass of the proton and the mass of a single atom of hydrogen is same. That's the reason. He said this whole atom, this whole total is a proton. This total is proton and this is also a hydrogen atom. This total weight, complete, this is proton. Complete part is proton. This is proton and this is hydrogen atom. Now question is, where are the electrons? Now according to Thomson, electron has a negligible weight because electron mass, I told you on my next lecture, electron mass is 9.1 into 10 to the power minus 31 kilogram, that is 27 gram. It is approximately negligible. Very small mass. I told you in my last lecture. 10 to the power minus 31 kilogram. That's the reason Thomson said electrons are embedded. E-M-B-E-D-E-D. Electrons, make a diagram. Electrons are embedded within the proton. Electrons are embedded within the proton like, now you please write like the watermelon. What is in watermelon? There is a red spongy part. The red spongy part of the watermelon is a proton. A proton and red spongy part is the one. Total weight of the watermelon is same as that of total weight of the watermelon dependent upon the red spongy part. And where are the black seeds? Black seeds weight is negligible. Black seeds of the watermelon embedded within this red spongy part. Same as that of black seeds of the watermelon embedded in the red spongy part, same happen in case of this proton, that is hydrogen atom. Again listen. Thomson's thought mass of the proton and the mass of hydrogen atom is same. That's the reason this total is the hydrogen atom and this total is the proton. And electron has a negligible weight, so electrons are embedded within the proton like the black seeds embedded in the red spongy part of watermelon. Same thing. So plum and pudding model it is also called. This model is also called plum pudding model. Plum pudding model. Same. So this is all about, but this model soon discarded because this model not satisfied our next experiment Now I'm going to take my second model along with the experiment. Write down. But this Thomson model was discarded sooner. Listen to me carefully. Now I'm taking your second topic. Rutherford atomic model. It was Thomson atomic model. Now sooner it will come Rutherford atomic model. Rutherford atomic model will come after Rutherford experiment. Okay. Now I'm taking first of all experiment of the Rutherford. Rutherford atomic model at the last. First of all experiment. Write down. It's a gold foil experiment. Rutherford alpha ray scattering experiment. I will take gold foil. I will take alpha ray. For alpha ray, the radium metal I will take. Radium is radioactive. Let us make a diagram. This is your lead block. Lead is the absorber of radioactive radiation. It's a lead block total. It's a block of lead metal. And this is your radium metal is placed within this small area. Now from this there is a rays, alpha rays, beta rays, gamma rays coming out. Now what is this? This is a very thin foil. Make it a gold foil it is. It's a gold foil. Gold foil it is. Before the, after that before. Before the gold foil again there is a sheet of, there is a single rod of lead with a slit. This is make a slit here. Slit, it is a slit in a lead shield, slit it is, so that at a very high pressure the rays come out from this slit. So these are the alpha rays, alpha rays, alpha rays, right on this alpha ray scattering experiment. So these are the alpha rays coming out from this radioactive element, passes through the slit and fall over this gold foil. This is a gold foil. When alpha rays are allowed to fall on the gold foil, the result taken on a round screen. It's a ZNS screen. It's coated with ZNS chemical. ZNS screen. Now scientists observed three things. The first of all, most of the alpha rays passed through the gold foil undeflected. Most, because a number of scintillation observed here. Where these rays struck with the ZNS screen, their fluorescence of light takes place, and scintillation, write down scintillation observed. Brilliance, fluorescence, that is your light started glowing, and scintillation, a point get marked there, scintillation observed. These scintillations suggest most of the alpha rays passed through the gold foil undeflected. Write down. First number, most of the alpha rays passed through the gold foil undeflected because a number of scintillation observed on the ZNS screen. Right. Now a very few alpha rays bends slightly, very few. Scintillation observed here. Very few alpha rays deflected to a small angle. And a very few. First is most of the alpha rays passed through the gold foil undeflected. Second, few alpha rays deflected to a small angle. And the third is some of the alpha ray, that is out of 20,000 just one. Out of 20,000 just one alpha ray come back. Struck with a gold foil and at once come, because it is a round flask, it's a round screen. So some of scintillation observed here. Most of the scintillation exactly, and in the front of that, few there, and a 1 out of 20,000 here. That is, third point is a very few alpha ray come back, bounced back when struck with the gold foil. So these are the three experiments, three observations. Now I'm going to explain each and every. Now first of all, again listen the experiment. Rutherford alpha ray scattering experiment. Lead block, radium, radioactive. Number of alpha rays come out, allowed that the number of alpha rays come out. This is your lead shield, this is a slit, so that in a very high pressure alpha rays come out, alpha ray allowed to fall on the gold foil. When fall on the gold foil, most of the alpha ray passed through the gold foil undeflected, and a number of scintillation observed in the front of the screen. A very few alpha ray deflected to a small angle, and a very few alpha ray come back. The question is why? Now let me explain. Gold is an element, gold is a matter, every matter has a particle nature, so I am taking one atom. Let it is an atom of gold. These are the alpha rays. Most of the alpha rays passed through the gold foil. Write down. First observations suggest in the atom most of the space is empty. Write down. The first observations suggest in the atom most of the space is empty. Most of the alpha rays passed through the gold foil undeflected. This means atom has a lot of space empty. Now I'm taking third observation first. Second I take later on. First and third now. Third. In between two I will take later on. Third now. A very few, that is out of 20,000, only one alpha ray come back because it hit with a very heavy thing present inside the atom, and we all know what is a heavy particle inside the atom. It is a proton. I'm going to write proton, you know all. Total mass of the hydrogen atom is exactly the same as that of proton. That means entire mass of the hydrogen atom depend upon the protons. Alpha ray is positively charged, proton itself positive. When positively charged alpha ray hit on the positively charged proton, it at once come back. This means inside the atom there is present proton in the central part, and this size is very small. Let the size is large, let just for a while think the area of the proton occupied is large, then most of the alpha rays come back. So that's the reason Thomson model discarded, because the Thomson model, this total was the proton. If this total is proton, that means every alpha ray have to come back. So because most of the alpha rays passed, this means this total is not a proton. So Thomson model discarded. And this is a proton. This is a very smaller sized, a very small area occupied by proton. That's the reason only one alpha ray come back, right? Small area covered. Now the alpha rays, because they are positively charged, which passes very close to it, very close, not hit to it, those deflected to a small angle. So this is the first point, this is your second point, and this is your third point. Write down kindly. So this is your three experiments. The first, most of the alpha rays passed through the gold foil because in the atom is a lot of empty space. Second, a very few alpha rays deflected to a small angle because they passes nearby to the proton. So that's a reason. So they deflected because positive repel each other. A very few alpha ray come back because they directly hit with the proton. Direct hit with the proton. After this experiment, Rutherford proposed a model. Now write down Rutherford model. According to Rutherford, atom has two parts. The one is nuclear part. Atom has two parts. The one is nuclear part and second is extra nuclear part. Write down atom has two parts. The one is nuclear part. Nuclear part is the part which is present in the center. This is nuclear part. There is a proton. And this is a proton area. Proton reside here. Proton occupy the nuclear part. After that, the rest part is the extra nuclear part. This extra nuclear part is the part where electron revolve. So this is electron revolve. This is electron. So he compared his model with the solar system, like sun, solar system, like sun in the center and planets move around the sun. In a similar way, when the planets moves around the sun, in the similar way, Thomson said electron moves around the nucleus. So this is a nucleus, you may call nuclear part. This is all extranuclear part. Electron is too negligible. Electron mass is 9.1 into 10 raised to minus 31, that alpha ray is passed through this without showing any deflection. Electrons has a unit negligible mass. Positive it is and negative it is. So never deflected when it struck with the electron. So electron not obstruct the path of the alpha ray, but the moment it hit with the proton, alpha ray, it come back. This is your proton and this is your electron. Proton is heavy, electron is light in weight. So now Rutherford compare his model with the solar system, remember. So according to Rutherford, electron will never fall into the nucleus, same as a planet during motion, never fall into the sun, because planet not only revolve around the sun as well as revolve on its own axis. In the similar way, Rutherford said, this is your proton, electron not only move around that is proton, it also rotate on its own axis. When electron rotate on its own axis, it is a centrifugal force which is acting outward. And when electron revolving around the nucleus, there is a force which is acting inside. It is called electrostatic force of attraction. Right on? Electrostatic. So during the motion of electron, two forces are coming. When electron moves around the nucleus, one force acting inward, electrostatic force of attraction, that is acting inward, and the other is centrifugal force which is acting outward. So students, you can write electron not only revolve around the nucleus as well as electron rotate on its own axis. These two forces balance each other, so electron will not fall into the nucleus according to Rutherford, right? According to Rutherford. Similar way, planet not fall into the sun, because planet not only move around the sun as well as rotate on its own axis. These two forces, I think you have written centrifugal force and electrostatic force of one force. One force means it's pushing inward, electron going inside. It look like it's a minus, it's a plus. But the other force is centrifugal force, which is acting outward. And students, a very important question, that size of the nucleus is very small. How you came to know the size of the nucleus is very small? The answer is because only one alpha ray come back. This means your size of the nucleus is very, very small. If the size of the nucleus is 10 to the minus 15 meter radius, then the atom radius is 10 to the minus 10 meter. Radius of the nucleus is so small from the atom. This is radius of atom, this is radius of the nucleus. This means nucleus is, you can check how much times smaller than atom. So nucleus is very, very small in size. Now this is all about the Rutherford model and Thomson model. Why Thomson model failed? Because according to Thomson, its total is proton. Every alpha ray has to come back. Every alpha ray has to come back. Alpha ray positive, this total is positive. Alpha ray positive. But no, only one alpha ray come back out of 20,000. That means this is total is not proton. Proton is just small area occupied in the nuclear part. This is all about. And the next topic we will take in the next lecture. Thank you.